Okay, so again, the first few problems are dealing with transformations, which is what we just completed. So the first problem says to graph the rotation 90 degrees counterclockwise. So on number 1, the first thing you should be doing is identifying the points on the grid. What is point Z? What is point Z? Let me fix this. Negative 4, 0. Okay? What is point J? Negative 5, negative 2. And then point L, 0, negative 3. Okay, so if I want to know what to do for 90 degrees counterclockwise, I'm going to go back into my notes where it says rotations, and I'm going to find where it says 90 degrees counterclockwise, and it tells me that this is what I need to do, negative yx. Okay? So over here, I'm going to write negative yx to show what happens to my coordinates. Okay? So I'll do this one with you. So you're going to flip your coordinates, right? So we would write 0 first, but we wouldn't write negative because 0 can't be negative. And then negative 4 would come last. It's going to stay the same. Nothing happens to the sign. So how would I write J? 2, negative 5. Good. Okay. And L?
3, 0.
3, 0. Okay, so your last thing that you're going to have to do is come over here and graph it. So if I graph it correctly, I have 0, negative 4, which is point Z1. We would put a little 1 at the top to represent the rotation. And then point J would be 2, negative 5. So we would put J like with a little exponent 1 there. And then point L would be 0, 0. No, sorry, 3, 0. Okay. So then you would just connect your lines here. Okay, and it should be a congruent figure. It's just being turned because that is what you do on a rotation. Okay, any questions on number 1? All right, on number 2, it says to graph the translation. I'm not going to do this one with you. I'm just going to show you again. You need to first identify your points. Okay, so you have F, G, and Y. That's your first duty there, is to figure out your coordinates. And then from there, you're going to figure out what to do here. So when it's talking about units to the right, is that referring to the X or the Y? Your X, because your X moves from left to right. Your Y is going to be the one that says 1 unit down, because again, the Y is up and down. So the way you would show that is you would show X. If I'm going to the right, which is this way, am I adding or subtracting? So you do X plus 4, and then Y, if I'm going down, am I adding or subtracting? Subtracting, good. All right, so just like we did in our booklet, you're going to, whatever the X is, you're going to add 4 to each one. Whatever the Y is, you're going to subtract 1 from each of those. Okay, so you're going to finish that up, and then you are also going to graph that new figure up here. Okay, moving on to number 3. Okay, so it says graph the reflection. If it's a reflection across the x-axis, again, you should be looking in your notes where it says reflection. And there's different steps for different types of reflection. So if we're reflecting it across the axis, I would look here, reflection and x-axis, and it's telling me that I need to do this to my points, x, negative, y. So you would start by identifying your points. This time you have 4 points. Okay, and then you are going to change those to x, negative, y for each one. So it's going to stay in the same order. your symbol for y is going to change on this one. So once you do that, you are going to graph those points into the grid. Okay, so the next one, moving down, is saying which transformation is being shown. So these are already graphed. What transformation do y'all think is being shown here? Translation, good. Okay, and you also know that because this is telling you that you're either adding or subtracting each one, which represents a translation. So that's your first answer right there. That's the first question. And then from there, how are you going to figure out what's happening each time? What do you need to look at? Your points. So you have C, H, and B, and then you have C1, H1, and B1. You need to figure out what those are, write them in, and then you need to figure out what's happening from X to X and Y to Y. Okay, so it's either going to be addition or subtraction of each one. Okay, moving on to the next problem, number 5. Okay, so if we're dilating an image, what does that mean? What operation is being used? What do we do in our notes for dilation? Multiplication. You're multiplying. You're multiplying each of these points by what number? So again, you have to first figure out your points. And then each one, you're going to multiply those by 2 to figure out the new points. And then you are also going to graph that there. Okay, on number 6, graph the image of the figure using the transformation given. First thing you need to do is you need to graph these. Once you do that, you're going to apply the rule for reflection across y equals x. In your notes on reflection where it says y equals x, I'm just going to show you real quick. At the top here, this is what you're doing to your points. So you are going to flip from x to y, you're flipping them from y to y to x. So you already have your points. All you're doing is down here, you're going to flip them and then graph. Okay, moving on to number 7. Again, this will be on Google Classroom for you guys. Okay, so again, dilation of 2. Now, what does dilation mean? Times, multiply by 2. All right, so you're going to graph these first. Then you're going to write them out, multiplied by 2, and then you're going to graph the dilation. Okay? Okay, moving down, you find the distance using the distance formula between each pair of points. Round your answer to the nearest tenth. Okay, so this is from like the second week of school. We have done this. We've done notes on it. First thing you need to do is figure out your points. Okay, so what is my first point over here?
Oh, -5, -5.
Okay, so we have -5, 5. And then my other point is which one? 1, -2. Okay, so this is where you have to label x1, y1, x2, y2, and then put it into this formula. Okay, solve the inside first, then find the square root. So this is probably going to require the use of a calculator. Okay? You're going to round your answer to the nearest tenth. Okay, moving on to number 9. Same thing. Same thing. You're using the distance formula. So same as number 8. Okay. Number 10. Write the equation in slope-intercept form of the line parallel and perpendicular to the given line through a given point. All right. So these notes are on pages 14 all the way to 17 where we did parallel and perpendicular lines. So you're going to tell me both the parallel and the perpendicular. Parallel lines have what? Same slope. Perpendicular lines have opposite reciprocal. Good. Okay. All right, moving on to the next one. All right, we're almost done here. All right, same thing here, but what is wrong with this equation up here?
It's not in y.
Yes, it's not in slope-intercept form, so let's do that together. How would I do that? Okay, so we're going to subtract 3x here. Okay, what do I have now? 4y equals 16 minus 3x, right? Or you could do negative 3x plus 16. Okay, and then I would what? Divide by 4, divide by 4. Y equals, if we're putting in slope-intercept form, then we would put this first. Negative 3/4 x, and then this is positive, plus 4. Okay? So I'm going from here to here. Now from there, I'm going to again find parallel and perpendicular to this line right here. Okay, almost done. All right, so it says write a conditional statement for a snake is a reptile. Remember, conditional means if, then. How could I write this as a conditional statement? If, what do y'all think? Yes, if a snake, no, it should be if, what is a snake? If an animal is a snake, then what? There you go. Then it is a reptile. Okay, so from there, I've done the first part for you. You're going to go through and do the converse, which means you're what? Flipping it. The inverse means you are keeping it the same as this, but then you're negating it. And then contrapositive means you're flipping and negating. Okay, so again, we do have notes over that as well. Okay? Okay, moving on. Almost done. All right, so number 13. Okay, so right here you're writing the converse for this statement right here. What does converse mean again? Flip. Okay? And then you're answering this question. Is this converse always true? If so, you're writing a biconditional statement. What is a biconditional statement? Yes. If and only if. Again, we have notes on this as well. That is going to be in your journals. Okay, and then the last two, I'm not really going to help you because we've done some problems like this. You're just telling me if the statement that you're reading on these two are inductive or deductive reasoning. Okay? All right, so again, you have till Monday to turn this in, guys. So tomorrow in class you may have time. If not, you have the whole weekend to work on it.